say, x squared minus 1 over x plus 1. This is kind of dividing polynomials, but it's really factoring and then canceling. And there is true dividing polynomials if you want us to do that. We can kind of actually do that today in a full lesson, or if you want to do some factoring first, up to you.
Were there different types of multiplying, or was it more like multiplying and then factoring?
Multiplying the most common case was like a binomial, like an x plus 3 times an x plus 4. But then it could grow. It could be like x plus 3 times x squared plus 4x plus 5. But they're sort of all the same, meaning you just multiply each one by each one of the other, and then collect terms and combine.
So it would be like 1 times 1 and 15 times 14?
Sorry, my handwriting is not very clean. It'd be like x times x, x times 4, 3 times x, 3 times 4. That's the multiplying. That's the FOIL.
Oh yeah, FOIL. I forgot about FOIL.
Yes. And then this one on the bottom, you take x and you multiply by each of these, 3 times each of these, and then collect terms and combine there.
I might have forgotten what to do.
Okay, so it sounds like we can do a little multiplying to start here. So let's do that. Let's take something very basic here, like x plus 3, x plus 6. So to FOIL, you start by taking x and multiplying it by x. X times x is x squared. Then you take the x and multiply it by 6, positive 6. So it's x times the 6, that's 6x. So notice we've taken x and multiplied it by both. Is that clear?
Yeah.
So then you take the 3 and you also multiply both. So the 3 times the x, that's 3x. And then 3 times the 6, that's 18. Now you don't normally write it off to the side like this. I'm just sort of restarting this topic so you can see like one really worked out example. But that is the path. You have to take the first times the first, that's the f. The outer ones, that's the o. X times the 6 is the o. The I is the inner, 3 times x, and the L is the last, 3 times 6.
Okay. And then you would combine usually the middle two, x and 3.
So you'd normally write
and then it would be 9x, right?
You got it. You got it. So this becomes x squared plus 9x plus 18. All right, so let's do one more example together before I maybe throw one or two at you to try with some signs. So let's say it's like x minus 7, x plus 5. So it's the same recipe, the same set of steps, just different numbers here. X times x is x squared. X times 5 is 5x. Minus 7.
Is it plus 5x? Okay.
Yes. Yeah, because the
oh yeah,
x
the minus
is positive.
is for the 7.
Yeah, exactly. Then you take the minus 7 times the x, and then the minus 7 times the 5, like that.
Yes. Okay. That makes sense.
All right, so let me have you try one here. Let's have you try x minus 4, x plus 6.
Thanks. And with the multiplying negative numbers, if they're both, if they're different, it's always negative, right?
That's right.
Okay. I think it's x squared positive 6x negative 4x negative 24.
Yes. So go ahead
Okay.
and simplify that for us, please.
And then that would turn into x squared. And then let's see.
6x minus 4x.
So it would be plus 2x.
2x, good.
Okay.
Minus 24.
And it is positive, right? Because
Yes.
6 is the bigger number. And
That's
then
right.
minus 24.
Yes. Okay, so let's try one now where they're both negative. So I'll give you one like that. Let's go x minus 8, x minus 2, like that, please.
And then it would be, and the x squared in the beginning would just be regular x squared, right? Because there's no negative. And
that's right.
then
Yeah.
inner negative 8x, outer. If they're both negative, does it make it a positive?
Yes.
Okay. So it's plus 16.
Yes.
And
What's
then
the product, or I'm sorry, the middle terms, what do they combine to?
hold on, wait a second. What's the wait a minute, I'm confused. Hold on first. Oh, confused. Okay, I missed one. It would be 2x.
Minus 2x.
Yeah, negative 2x and then negative 8x. And
Good.
so it would end up being x squared negative, no,
Minus 10x.
yeah, minus 10x.
Plus
Because
6.
it would be if they're both negatives, you add them, right?
Yes.
Just regularly and put the negative sign.
Right.
And then it would be plus 16.
Mm-hmm.
That makes sense.
All right. Do you want one more? Can we move on to the bigger multiplying problems?
The bigger multiplying problems.
All right. So let's say it's x plus 3 times x squared minus 2x plus 5. All right. So this is, the name isn't really important, but it's binomial 2 terms times a trinomial 3 terms. You saw me before drawing kind of these paths. You really want to do the same thing here. It's like x times x squared. That's x cubed. Then you draw another path from x to minus 2x. You're going to multiply those. That's minus 2x squared. Then x times 5, 5x.
Oh, so you add the exponents, so it would be technically 1 and then 2.
That's
So
right.
3.
X1 times x squared is x to the 1 plus 2, x cubed. Good.
And then negative x squared plus 5x. Do you do anything with the 3 or I
Yeah,
forget?
you keep going here. See 3 times the x squared, that's positive 3x squared. 3 times the minus 2x minus 6x. And then 3 times the 5, that's plus 15. And then you add everything together. You combine like terms.
Negative 6.
So x cubed plus x squared minus x plus 15.
And everything with the biggest exponents goes first, right?
Yeah, it's preferred in descending order. They might ask you like, what's the coefficient of the leading term, or what's the degree of the polynomial? And all comes from this first one here.
Positive x squared plus negative x. A positive, it would be positive plus x. No. Yeah, it would be positive 3x squared plus negative 2x squared.
Are you giving me the final answer, or you help me out here? I guess.
And I'm trying to add them.
Okay, so you want to add them vertically, like they're kind of in columns here where they go together.
So I can only, even if there's 3 regular, oh wait, those are both x's, never mind, that looked like a plus for a second. Okay, so there's a perfect amount to add together.
Yes.
So 3 and 2. So that'd be positive 1?
For what? For which one?
3 and 2.
Yes. So that's positive 1x squared.
So would you just write it as x squared?
Either way, I mean, it will not be presented as 1x squared, but it's okay to write that.
And then it would be the same thing, but negative 1x and then plus
That's
15.
Right. Yes. So I should give you one to try. Just one. I mean, these do take a little longer, but it's good to do. Is that okay?
Yeah.
All right, we'll not make it super weird or anything like that, but let's go x minus 2, x squared plus 3x minus 1, like that.
Okay, so first the x times x squared. So the first one would be x3 cubed. Or cubed. What's it called when they're 3? Is that cubed?
Yes.
Okay. And then 3x plus 3x squared.
Okay, that's correct. And then what's the last one? X times minus 1.
And then that would be negative 1x.
Good.
And then the second line would be negative 2x squared. And then would that just be positive 6x because or no, it would be negative 6x because it's multiplying, right?
Yeah, so it's minus 2x squared for the first one, and then minus 6x for the second one.
Minus 6x, and then negative 2 times negative 1. Would that just be negative? Would that be regular 2?
Yes, positive 2.
Okay. And then plus positive 2. So it would end up being x cubed, and then positive 1x squared.
Good. Yep.
And then would be negative 7x.
Yes.
And then plus 2.
You got it. Okay, so that's kind of multiplying. I don't think we need to spend any more time on that.
Yeah.
We could talk a little bit about factoring again, if you would like. Or, you mentioned dividing polynomials. We can also go that direction. Do you have a preference?
We could just like list the types of factoring again, just kind of go over them, make sure I remember, because I was focusing mostly on the factoring, so I forgot some of the multiplying.
Yeah, so the first type of factoring is the greatest common factor. And it would be like something like this, like 8x cubed minus 6x squared plus 4x. And the greatest common factor is both a number and a letter. So it's the number that goes into 8, 6, and 4, which is 2. And then it's the smallest exponent of x, which is 1. And then you're dividing each of these by 2x. Does that look at all familiar to you?
No.
Okay, that's okay. We can do several examples if you'd like. That's the first type of factoring, is the greatest common factor. So the what goes in parentheses here, you're gonna take 8 divided by 2, so that's 4. And then x cubed over x1 ends up being x squared. You subtract the exponents. So this is 4x squared. This is like going backwards from multiplying. Like, do you see that 2x times 4x squared is 8x cubed? 2 times 4 is 8. X times x squared is x cubed.
Mm-hmm.
All right, let me just create a little space here. Now for the next one, 6 divided by 2 is 3. 2, it's x to the 1, so that's 2 minus 1 is 1, so that's 3x, like that. And do you see that if you take the 2x and multiply it in times the 3x, you get the 6x squared?
So you multiply the big numbers and then you subtract instead of add the exponents?
Well, if you're going down this way, you're dividing and then subtracting the exponents. But if you're multiplying in, then you do add the exponents. Which direction are you referring to?
I didn't know there was more than one direction.
Well, it depends if you're trying to divide or if you want to multiply in to go back.
Oh, I guess I was talking about the dividing. I thought you were multiplying for a
Okay,
second.
so when you divide, 8 divided by 2 is 4, and you subtract the exponents.
Okay. That makes more sense.
The last one here, 4 divided by 2 is 2. Because they both have an x, it just cancels. Whenever you just have the same degree on the top and the bottom, x to the 1, x to the 1, it just goes away.
Okay.
All right, do you want me to give you one like this to try?
Mm-hmm.
Okay, let's say it's 15x to the 4th minus 9 x cubed plus 3x squared. Let me know when you've got your GCF, the thing that goes on the outside. It's pretty important to get that right to be able to move forward on this.
Is it 3?
3 is the number. What about the variable? It's x to what power?
Would it just be regular x?
It's always to the smallest exponent. So in the first example is 1 was the smallest one. So this time it'll be at 2. All right, so you're essentially dividing each of these by that greatest common factor.
Two. So 15. So x squared. And then the second one would be a minus, right?
Yes.
Or negative? Okay. And then negative 3 x, right? Because it would just be x1.
Yes.
And then And then would that just be +1?
+1. You got it. Okay, so that takes care of greatest common factor. That's the first type of factoring. Let's, the type number 2 is what's called difference of squares. So if I give you a couple examples, I think it will you'll quickly remember what this is. X squared minus 9 becomes x minus 3, x plus 3. And the reason it's x minus 3, x plus 3 is because this is really x squared minus 3 squared. So notice the 3 and the 3 get used in there. So let's say it's x squared minus 36. So you have to figure out what number squared gets you to 36. That's really the hardest part of this. This is 6 squared. So it's always a positive and a negative inside parentheses there. Does this look familiar to you?
That one looks a little more familiar.
Okay. So the hardest part is really
So it's
figuring out
just it's finding out the square root.
exactly. Yeah. So I give you one like this, like x squared minus 4. Why don't you try this one for me, please?
Let's see, x squared minus 4. So it would be x minus 2x plus 2.
Yes. We did a lot of variations on this, but this is the kind of the base case of it. Like we did some other things, like we did like 9x squared minus like 49y squared. We did some more complicated ones, but it comes down to figuring out like what squared minus what squared. Like you have to figure out what goes in parentheses here, because that's what's called your A, and then the other one's your B. So we did some more complicated ones, but I'm not even sure that you'll need those. 3 squared is 9, x squared is x squared, 7 squared is 49, y squared becomes y squared. And the whole point of this is to figure out, well, it becomes 3x minus 7y, 3x plus 7y.
Okay, that's not much more complicated. That's just writing it out a little more.
Yeah, so let me give you one here. Let's go like 25x squared minus, let's go keep the numbers pretty small here, 16y squared.
25 y squared minus 16y squared. Both y?
X. First one's X. First one's
Oh,
X.
sorry. I said y. Okay, 25x squared. So it'd be 5.
5 definitely gets you the 25. What else? What else?
Wouldn't it be 5 times 5?
It is, but the 5 times 5 gets you 25. You're trying to figure out what goes in parentheses so that you get back to 25x squared. Like 5 times 5 is 25, but you got to get back to x squared. Do you see how I put an x here in this?
Oh yeah, I didn't mean there was no x. I was just saying that it's 5 the square root number.
Sorry. Yes.
And then x squared, or yeah, and
Just
then
x. Just x. Yeah. Minus.
and then but the squared is. Do you put the squared after the parentheses?
Yeah, because there's really a 1 here, so 1 squared is gets you back to the x squared. Like you're trying to figure out how to go backwards with this line.
And then is the other square root 4?
Yes.
And then 4y.
Good.
So then in the end it would end up being 5x minus 4y, and then 5x plus 4y. Right?
Yep. Good. So that's difference of squares. The next one after this is perfect square trinomials. All right, so I'll give you an example one. Let's say it's x squared plus 6x plus 9. So this becomes x plus 3 times x plus 3. And the thing that's really similar to the previous ones is you have to take the square root of this last one. The square root of 9 is 3 and 3. The way this is typically written, though, is you combine them, so it's x plus 3 to the power of 2. Is that okay?
Kinda.
All right, we're gonna do a couple more. Let's say it's x squared plus 10x plus 25. You take the square root of the last number here. That becomes x plus 5 squared.
Is that the only thing you need to do?
Yes. Now let's just confirm this through FOIL.
And
So,
it always has to be the middle one?
well, when you FOIL it, it should give you 10x. It should give you all three, but it'll also give you the 10x. Do you mind foiling this just to confirm that it is this on the left here? That might help your unbelief, we'll say.
So it would be x plus 5. And you always do the last one?
Well, when you're factoring it, yes, but I'd like you to FOIL this so that you can see that it does in fact get you back to this here. Is it clear what I'm asking you to do?
You always just find the square root of the last one?
Yes.
And then what do you
Well, I'm asking you to,
do you always do x plus square root or
yes, yes,
and then is it always 2 with the exponent?
yes.
And then x times 5 plus 5x, and then inner is also plus 5x, and then plus 25, which would be, yeah, and so it gets you back to it.
So it does work. Okay. So let's have you try one now. Let's say it's x squared plus 14x plus 49. What does that become?
Let's see. Square root. 7, so it would be x plus 7 and then squared.
Yeah, you just leave it like that. Good. Okay, now the other type of perfect square trinomials, it's really similar here. Let's say I put a minus in front of the 14x. This becomes x minus 7 squared. So
So at the end is it 5 plus, would it be like plus x or x? Okay, it's x plus the number.
yeah, but it depends on the sign. Like if it's
Or
plus
if it would
plus
be negative
plus,
the number if it's negative.
yeah,
Okay.
exactly. Let's try a couple here. Let's say it's x squared minus 20x plus 100. What does that become?
So it would be would you still do the last one?
Still do the last one. Square root of 100.
Is that 10?
It is 10.
So would it be x minus 10
Yes.
and then square? Okay, that makes sense.
How about x squared minus 8x plus 16?
So it would be x minus 4 squared?
Yes. Last one here for this type. Let's go x squared minus 2x plus 1.
Mhm. Would that just be x minus 1 squared?
Yes. All right. Job. We got another type of factoring to do. So the next type of factoring here is what I call a equals 1. So these are of the form x squared. And then there's another term like a plus bx plus c. But this b could be positive or negative. The c could be positive or negative. And we went through the various different cases. So let's just try a few of these. Let's say it's like x squared plus 7x plus 12. So notice like you cannot take the square root of the last number. It doesn't work out nicely. But what you can do is you can write the factors of 12 and see which ones actually add up to 7. So like
Oh,
think of
this is the
two.
one I remember doing the most of, I think.
Oh, good. Good. So it's two numbers that multiply to 12 but add up to,
Add up to 7.
yeah.
So would it be 4 and 3?
Yes. So it becomes x plus 4, x plus 3. Order doesn't matter. Now this is the nice case because they're both positive.
And then when they're negative and negative, you have to, all of the things are, there's one where they're all negatives, like
Right.
only write down the negatives, and there's one where you write down the alternating variations that you could do.
Exactly here. Yeah. So the next problem here is one of those. You're trying to find two numbers that multiply to 24, but add to negative 14.
So for this, is this one where you would do alternating, or would you only negative?
So I can give you the answer, but there's an intuitive way to, like, 1 times 24 is 24, but these are both positive, and that definitely won't work. So if you make
So
them
this is the
both,
alternating one?
but if you make them both negative, does it still multiply to 24? Yes, but then does it now add up to a negative number?
I don't remember.
That's why I'm just looking, like, is -1 plus -24, is that a negative number? Yes. So like,
Oh,
so this one is the one where they have to both be negative.
okay. So yeah, it would be -1, -24, and then it would,
Yes. So we're
okay,
trying to
you would
find
go
two
down
numbers.
like 2.
Yeah. So what is what's the one that works here?
Is it 12 and 2?
-12 and -2.
Oh
Yeah.
yeah, yeah, -12, -2.
Okay. Very good. So let's give me one more of those. Let's say it's x squared minus 13x plus 36.
Mm. Is it -4, -9?
Yes. So x minus 4, x minus 9. And I like the way you said the last kind of case here is where they alternate. That's kind of the most problematic one. So for most students, it's be like something like x squared minus 6x minus 7. This is where one's positive and one is negative.
When they're both negative?
Well, yeah. So when these are both negative, they're both one is positive, one is negative.
So it would be, you would do 1 and -7 and then -7 and 1. And so then it would end up being -7 and 1.
Yes. So x minus 7, x plus 1. All right. So I'm gonna give one just a tiny bit more difficult here. Let's go x squared plus x minus 20. So this is also the possibility where they alternate in signs. One's positive and one's negative.
Let's see. So for 20, -20 and 1. Two and -5, -5 and 2. So I have to get it to 1,
Positive 1, yeah.
positive 1. Oops, had the wrong number. So it's 10. Oops. And then oh, I think I see what it is now, because I messed up one of the numbers before. So I think it's 5, +5, -4.
Good. Yeah. X plus 5, x minus 4. All right, so the very last type of standard factoring, I looked in our notes. I actually didn't see us do any of these. I don't even know if we should. It's called grouping. It's the most difficult type. It would be something like 2x squared plus 5x. I'm sorry, plus 5 down here, and then it would be like plus 7x, something like that. And I don't think we actually did any like this, so I'm not sure if we should do any, because I mean, this is kind of the extreme, tentacles edges of it, but we can talk about it. It's much more difficult though, a little longer to do.
What do you do for it?
Yeah, so you take the first number and multiply the last. So that's 2 times 5, which is 10. Then you look for all the factors of 10 that now add up to 7. So it's kind of the same as the one we we're just doing, but you'll see in a moment that it gets a little bit rougher. So 1 in 10, 2 in 5. Do you see how 2 and 5 add up to 7?
Mhm.
So what you do is you break apart this 7x, and we're going to break it apart into 2x plus 5x. Bring the 2x squared down, bring the 5 down, and now we do what's called grouping. So we group these first two together, and you have to find the GCF of the first two. Do you see that it's 2x? 2x goes into both of those?
Mhm.
All right, so now we got to divide each of these by 2x. So what goes in parentheses here?
So that would just be x plus x, right? Because
1. The x's cancel.
oh,
Okay. Now this is kind of the awkward part. So after you do this, you immediately write what's in parentheses over here to the right. And you may not know why at the moment, but that's the procedure. So then there's this kind of this placeholder here, and you got to figure out what number goes in here such that when you multiply in, you get back to the previous line. And it's good to kind of look at that constant. So 5 times 1 gets you back to 5. 5 times x gets you back to 5x. Is that any questions on that before we move to the final step?
so it's what gets you back to the last two numbers.
Yeah.
Okay.
All right. Now, this is the last step. It's maybe equally unclear that this can happen, but because x plus 1 is the same in both, you factor that out. And then what's left over, the 2x plus the 5 go in parentheses.
Yeah, there's a lot of steps.
Yes, yes. Would you like us to do another one?
Yeah.
All right. Let me grab one here. Just found good worksheet on this. So let's do another one here. 5x squared plus 19x plus 12.
And what's the first step you do?
You take the leading coefficient and multiply it by the last. So 5 times 12, that's 60. Then you got to find two factors that multiply to 60 but add to positive 19. So I'm going to give those to you just because that could take the longest, 15 and 4. And so this 19 breaks apart into 15x plus 4x.
And then you
You look at the first two
divide.
terms, and see what's the GCF between them. So what goes
5.
into both? Yeah, 5, and then what's the smallest x term or exponent?
1.
X. Yeah, so you're dividing each of those by 5x. So can you tell me what goes inside parentheses when you divide each of those by 5x?
So it would be x. And then 3.
Good. And then you immediately write that over here to the right.
And then what do we have to find?
The number that goes here such that when you multiply in, you get back to the previous line. So like, what do you multiply 3 by to get 12?
Oh, so it would be 4.
Plus 4.
And then it would be the same. So it would be the x.
Yeah. So now you factor both out, x plus 3, and then 5x plus 4.
Okay, that makes more sense now.
And then just real quick, because we don't have much time here, if we were to FOIL this, you can see that it does get you back to the original. X times 5x is 5x squared. X times 4 is 4x. 3 times 5x is 15x. 3 times 4 is 20. Sorry, 12. Wow. Ooh, that's bad. So 5x squared plus 19x plus 12, and that is the same as what we started with.
Okay.
All right, so we do have to stop here for tonight.